All right, let's do it. We're doing net signed area. What the hell is net signed area? When we started this section, we said f of x had to be non-negative, or not this section, but like this chapter. We said f of x had to be non-negative. The definition of the definite integral doesn't have that requirement, though. That looks really big the way I've got it this size. I must have written and zoomed out. So what do we do if f of x is negative? That looks bad. What do we do if f of x is negative? Well, any area below the curve is counted against the overall area. It's treated as a negative value, and I got a picture here for you. So like, let's say we're getting this region right here, and we're doing the integral from 0 to 2 of f of x dx, and we see f of x is like that. It's doing the area between that value and the x-axis. Now, if it's above 0, it's positive, but if it's below 0, like down here, it's negative. So we could either say a1 minus a2, or effectively another way of looking at this is like a1 plus negative a2, because a2 is like a negative area. Okay. Let's take a look at negative 4 to 4, the limits of integration on x dx. We have we're going to put a1 as the right triangle, a2 is the left triangle. Triangles are 1/2 base times height. If we do this on both of them, we get 8 and 8 on both of them. That 8 looks bad. And so if we do a1 plus negative a2, or a1 minus a2, we get 8 minus 8, which is 0. So the net signed area for that graph is 0. Okay? That's how this works. Get rid of that right there. There we go. So let's find the net signed area of y equals x minus 1 from negative 1 to 5. I sketched it out here for us. So I'm going to call A1 the positive triangle, A2 the negative triangle. This has a width of 4, and it looks like a height of 4. But if you can't recognize that or spot that right away, you can always subtract values here. So I did 5 minus 1 right here to reflect this being 5 minus 1. And I did 4 minus 0 here to represent this being 4 and that being 0. Okay? So you can plug it in and do it that way. It ends up being 4 and 4 for both of them. So A1 is 8. A2, we have, I did the same thing here. 1 minus negative 1 for my x, or my base. 0 minus negative 2 for my height. And both of those turn into a plus. Double negative is a plus, and that's 2 times 2 times 1/2 gets us 2. So if we do A1 minus A2, we get 6. So that's how net signed area works, and that is how indefinite integrals work. These are how an indefinite integral works. Indefinite integrals. Oh, we haven't gotten to indefinite yet. Yeah, we are. We're doing indefinite right now. No, I'm sorry, definite. Indefinite was yesterday. Definite integrals calculate net signed area. You're gonna get really mad later on when we introduce infinity. I know I did. You'll see. So what if we don't want net signed area? What if we don't want to subtract out the bottom? What if we really want to like have the total area? So when we want the total area, the definite integral doesn't work as it is. We can't just do the integral from a to b f of x dx. We can modify it so that it will do what we want to, though. And the problem is here. The problem is over here where f of x is negative. Okay? F of x less than 0 is a problem. So the way we deal when we don't want a negative number, but we want the positive value, we take the absolute value sign. So we can use the absolute value of f of x rather than f of x. So if we do total area of the integral from a to b of the absolute value of f of x dx, it is doing, I want to change that. It is doing absolute value of a1 plus absolute value of negative a2. And you'll see why it's doing it. It's separating it up into two integrals. It's doing an integral for this region, and then it's doing another integral for this region. And we'll see why in the next video when we do the properties of integrals, or definite integrals. So let's say we want to find the total area of y equals x minus 1 on negative 1 to 5. That's the picture, that's the graph we just have right there. Y equals x minus 1 on negative 1 to 5. We don't need to redraw it. I did copy it and put it down here, though. I even copied the information and put it down here. So when we're doing it, it's getting this the absolute value of each one. So we get 8 plus 2 rather than 8 minus 2. And we get a total area of 10. Okay. The one we did before, y equals x on negative 4 to 4. Take a second and calculate the total area there. I will assume you did. Remember when we drew it, if we broke it up, each triangle was 8. And when we did it before, we were doing 8 minus 8, we got 0. Here, we're adding them together, we get 16. Okay? Next video will be properties of the definite integral. Oh, good stuff. Peace.